morning, dear students. I am Gajendra Prasad from +2 High School, Begabad, GIRIDIH. Today we will understand and find an expression for electric potential energy of a dipole in a uniform electric field. As shown in the adjoining figure, it is an electric dipole of 2 point charges plus q minus q separated by distance 2l placed in uniform electric field E. And we have to find the electric potential energy of this dipole placed in uniform electric field. So we write here as shown in the adjoining figure. Consider an electric dipole. As we know that a dipole consists of two equal and opposite point charges separated by some distances. So this is a dipole consisting of 2 point charges plus q and minus q separated by distance 2l. We consider this point as the center of the dipole, and this length L and this length L, and the complete length of the dipole is 2l. So this is a dipole consisting of 2 point charges minus q and plus q separated by distance 2l placed in a uniform electric field. Placed in a uniform electric field E. We suppose this theta is the angle between the direction of electric field and the dipole moment P. So we let theta is the angle between, let theta is equal to, theta is the angle between theta is the angle between the electric field. You can write angle between the direction of electric field E and the dipole moment P. We have already discussed what is dipole moment. Dipole moment is the product of the magnitude of any point charges of the dipole and the distance between the 2 point charges. It means the product of any point charges q into the distance 2l. It is the dipole moment. We have already discussed it in previous videos or classes. So this theta is the angle between the electric field, between the direction of electric field and dipole moment P. Okay. Next, we have written here plus QE and minus QE. As this we know that electric field intensity is defined as the force per unit test charge Q, force acting on per unit test charge Q. So from here this definition, this expression of electric field intensity we have written here F force is equal to plus QE, force acting on this point charge on this side is Q plus QE, and the force acting on this side is minus QE. So we write here plus QE and minus QE. Actually these two forces these two forces acting on the dipole forms a couple, and it is called a torque. It is called torque. So we write here plus Q and minus QE, two equal and opposite forces, two equal and opposite forces acting, two equal and opposite forces acting on the two ends of the dipole, acting on the two ends of the dipole, which forms a couple, which forms a torque. So we write the torque acting on the dipole hence the torque acting on the dipole is, this torque is written by the symbol tau is equal to force into perpendicular distance, we see here that here is the force acting on the two ends of the dipole is plus QE and minus QE, and the perpendicular distance of this force is 2L sin theta. Perpendicular distance of this force is 2L sin theta, as this distance is 2L, so this part becomes 2L sin theta. You know that the projection of a vector like this, if this is R, this component is this resultant is R, then base component is R cos theta and the perpendicular component is R sin theta. So by this concept, this perpendicular distance is 2L sin theta. So we write here force is, the magnitude of the force acting on the two ends of the dipole is QE and the perpendicular distance is 2L sin theta. So we write torque acting on the dipole QE into 2L sin theta. This we can write Q into 2L into E sin theta, and this Q test we have discussed that product of the magnitude of any charges and the distance between the two charges is defined as the dipole moment. So we write here, we can write here this Q into 2L as PE sin theta, where we write tau is equal to P sin theta. We consider this equation 1, and here we write here P is equal to Q into 2L is equal to dipole moment. So this is the torque acting on the dipole. If the dipole is rotated through, now if this dipole, here the angle theta is the angle between the direction of electric field and the dipole moment. If this dipole is rotated through a small angle d theta, right here, if the dipole is rotated through a small angle d theta, rotated through a small angle d theta against the torque, against the TORQ, against the torque acting on it, then the small work done will be, as we know, work is defined as the product of force and displacement. So here force is the torque, equation 1. Force is the torque acting on the dipole, and the displacement is the small angle d theta. So we can write work done. So this will be work done, small work done will be dW equal to tau d theta, and this will be value of tau we have obtained in equation 1, PE sin theta. So we can write here PE sin theta d theta using 1. We can write here, this is the small work done in rotating the dipole through a small angle d theta. We can write this equation 2. Now we can find the total work done in rotating the dipole from its orientation. Hence we write, therefore the total work done in rotating the dipole from its total work done in rotating the dipole from its orientation, making angle theta, angles theta 1 to theta 2 with the direction of the electric field E the direction of electric field E will be W is equal to integration of dW. The integration sign represents the total. This is equal to value of dW into, we have obtained PE sin theta d theta. So it will become total work done. W is equal to integration of dW. This is equal to integration from theta 1 to theta 2 PE sin theta d theta. This is the total work done in rotating the dipole from its orientation, making angle theta 1 to theta 2 with the direction of electric field E. Now break this integration. This is line, right? W. Here P, the dipole moment is constant and the electric field is also constant. So it will become PE integration from theta 1 to theta 2 sin theta d theta. As we know, the integration of sin theta is minus cos theta. So we write here PE minus cos theta from, we write the limits of the integration theta 1 to theta 2. This will become PE. Now we put the value of once upper limit then lower limit in place of theta. So it will become minus cos theta 2 and here will be minus and outside is minus, so it will become plus cos theta 1 and finally it will become PE cos theta 1 minus cos theta 2. Cos theta 2. This is the value of work done in rotating the dipole from its orientation. We can write this equation 3, or this work done in rotating the dipole from its orientation is stored as the potential energy of the dipole. So it will become, this work done will be equal to the electric potential energy of the dipole. We consider this equation 3 and we write this work done is stored as the this work done is stored as the electric potential energy of the dipole. Electric potential energy, we write in short PE of the dipole. So we can write electric potential energy is equal to work done is equal to PE cos theta 1 minus cos theta 2. We can write this as equation 4. If initially this dipole is held perpendicular to the direction of electric field, it means ये जो डाइपोल है शुरुआत में यदि इलेक्ट्रिक फील्ड के साथ परपेंडिकुलर हो, इट मींस इलेक्ट्रिक फील्ड दिस एंगल थीटा इज इक्वल टू 90 डिग्री, थीटा 1, दिस एंगल थीटा 1 इज 90 डिग्री when this dipole is initially held perpendicular to the direction of electric field, that is theta 1 is equal to 90 degree, and then brought some orientation making angle theta, that is theta 2 is equal to theta, then it will become right here, if initially the dipole is held perpendicular to the direction of electric field, that is theta 1 is equal to 90 degree, and then brought to some orientation, making angle theta, that is theta 2 is equal to making angle theta with the field, that is theta 2 is equal to theta. Then the potential energy, this expression, the expression for potential energy of the dipole will be then we can write here, then from equation 4 the expression of electric field, expression of electric potential energy of the dipole will be as we have discussed that this theta will be equal to 90 degree and this theta 2 will be equal to theta. So here the expression of electric potential energy will be equal to U is equal to PE cos 90 degree minus cos theta. Now as we know that value of cos 90 degree is equal to 0, so it will become minus PE cos theta. Now if we express this Pe cos theta, this can be now this expression of electric potential energy can be expressed as the dot product of the dipole moment P and the electric field E. So this can be written as U is equal to minus P dot E. We write in one line, this U is equal to minus Pe cos theta is equal to minus P dot E. So this is the final expression of electric field, final expression of electric potential energy of dipole placed in uniform electric field. We consider this equation 5. Now there will be some special cases that the cases will be the position of dipole in stable equilibrium and unstable equilibrium. There will be three cases. One is position of stable equilibrium, and second is position of unstable equilibrium of the dipole, and the third position is the position of zero potential energy. We see how this will be obtained. Special cases. Case 1. Case 1 is the position of the stable equilibrium. Position of the stable equilibrium of the dipole. It means in this case we will see that how this dipole will be in stable equilibrium. ये dipole द्विध्रुव कैसे होगा, स्थायी संतुलन की स्थिति में कैसे होगा. As we are considering that this is the, we are finding here the expression for electric potential energy of a dipole. In the case of when the dipole is rotated through a small angle, or when the dipole is rotated, it means जब ये dipole rotation में होता है, then what will be there with what will be the condition of its stable equilibrium. अस्थाई संतुलन का क्या कंडीशन होगा, अस्थाई संतुलन में कैसे होगा और अस्थाई संतुलन में कैसे होगा. What will be the conditions for the two cases? It means यह डाइपोल, यह द्विध्रुव जब रोटेशन की स्थिति में होगा तो अस्थाई संतुलन में कब होगा और अस्थाई संतुलन में कब होगा, उसके लिए क्या शर्तें होंगी. So we see here we have obtained here the final expression for electric potential energy of the dipole. E is equal to minus Pe cos theta is equal to minus P dot E. This is the final expression. By this expression we can find the three conditions. First condition is the position of the stable equilibrium of the dipole. When will be stable? When a dipole will be when in a stable equilibrium. You see here expression for electric potential energy is Pe cos theta, and as we know, if we put here the value of theta is equal to 0 degree, value of theta is equal to 0 degree. It means when this dipole or dipole moment is in the direction of electric field E, if theta is equal to 0 degree, if theta, value of theta means angle between the direction of electric field and dipole moment P is 0 degree. It means when this dipole is parallel to the direction of electric field E, then the theta value of angle will be 0. So we write when theta is equal to 0 degree, when theta is equal to 0 degree, that is when the dipole or dipole moment, when the dipole is parallel to the direction of electric field, direction of electric field E, then cos theta is equal to cos 0 degree and it is equal to 1. So from this expression 5, hence U is equal to value of electric potential energy of the dipole, it become minus PE, and this is the value of minimum, this gives the value of minimum potential energy, this gives the minimum potential energy of the dipole, and hence this is the position of stable equilibrium. This gives the value of minimum electric potential energy of the dipole and hence this is the position of stable equilibrium of the dipole. It means कि जब डाइपोल इलेक्ट्रिक फील्ड इंटेंसिटी, इलेक्ट्रिक फील्ड के डायरेक्शन के साथ पैरेलल की स्थिति में हो, इट मींस दिस डाइपोल इज इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड, देन द वैल्यू ऑफ इलेक्ट्रिक पोटेंशियल एनर्जी विल बी मिनिमम. इट मींस जो ऊर्जा का मान होगा, स्थितिज ऊर्जा का मान होगा, वह न्यूनतम होगा, और तब ऐसी स्थिति में यह जो डाइपोल है वो अस्थायी संतुलन की स्थिति में होगा. इट इज क्लियर. दिस केस पोजीशन ऑफ स्टेबल इक्विलिब्रियम. नेक्स्ट वी सी द केस 2. Case 2. Position of unstable equilibrium of the dipole. You see here that the value of electric field, electric potential energy P E cos theta. So if we put here value of theta is equal to 180 degree. Value of theta is equal to 180 degree. It means this angle theta 180 degree. It means the position of this dipole or the dipole moment will be anti-parallel to the direction of electric field. This electric field, when theta is equal to 180 degree, then the direction this dipole will be anti-parallel. ये विपरीत इलेक्ट्रिक फील्ड इंटेंसिटी के इलेक्ट्रिक फील्ड की दिशा के विपरीत में होगा, उल्टा सीधा स्ट्रेट में होगा. So we write when theta is equal to 180 degree, that is the dipole is held anti-parallel to the direction of electric field E, then the value of cos theta will be equal to cos 180 degree and its value is -1. So the value of electric potential energy will be equal to U equal to minus PE, and the value of cos theta is equal to cos 180 degree and its value is -1. So it will be equal to plus PE, and it is the this gives the maximum potential energy. This value of plus PE gives the maximum potential energy, maximum value of electric potential energy of the dipole. This gives the maximum value of electric potential energy of the dipole and hence this is the position of unstable equilibrium, position of unstable equilibrium. It means कि जब यह डाइपोल इलेक्ट्रिक फील्ड के दिशा के विपरीत हो तो इलेक्ट्रिक पोटेंशियल एनर्जी का मान अधिकतम होगा और तब यह डाइपोल इस यूनिफॉर्म इलेक्ट्रिक फील्ड में अस्थायी संतुलन की स्थिति में होगा. सो दिस इज द केस ऑफ दिस इज द पोजीशन ऑफ अनस्टेबल इक्विलिब्रियम ऑफ द डाइपोल. नेक्स्ट we discuss the third case. Case 3, special case 3, position of zero energy. Position of zero electric potential energy. When will be the zero potential energy? if this theta, it means the angle between the dipole moment and the direction of electric field is 90 degree. That means the dipole, when the dipole is held perpendicular to the direction of electric field, when theta is equal to 90 degree, theta is equal to 90 degree, that is when the dipole is held, when the dipole is held perpendicular to the direction of electric field E, then cos theta will be equal to cos 90 degree, and as we know the value of cos 90 degree is equal to 0. So the expression for electric potential energy, hence U of the dipole, electric potential energy of the dipole will be equal to PE cos theta. We know that the value of cos theta, we have cos theta is equal to cos 90 degree, PE cos 90 degree, and it is equal to 0. So thus the electric potential energy of the dipole is 0 when it is held perpendicular to the direction of electric field. Thus the value of electric potential energy electric potential energy of the dipole is 0 when it is held perpendicular to the direction of electric field E. When it is held perpendicular to the direction of electric field E. So these are the three special cases of the electric potential energy of the dipole. Related questions are asked from this topic. I am writing the question. Define the term electric dipole moment. Define the term electric dipole moment. Define the term electric dipole moment. डायपोल मोमेंट यहाँ पर हम लोग ने डिस्कस नहीं किया क्योंकि पहले के वीडियोस में ये डायपोल मोमेंट का था डेफिनेशन. It is very simple. The definition of dipole moment is very simple. That is, the product of the magnitude of any point charges of the dipole. We have already discussed in the topic, in the discussion, that Q into 2L, it is dipole moment. It is a vector quantity and it is the product of the magnitude of any point charges. It means there in the dipole there are two equal and opposite point charges. One is plus Q and another is minus Q. Minus Q plus Q. There are 2 point charges separated by some distance. The distance O is the center of the dipole and the complete distance, this LL, the complete distance is 2L. So the product of the magnitude of any point charges and the separation distance is called dipole moment. So it is very, this definition of dipole moment is very simple. That is product of the magnitude of any point charges and the distance between them is called dipole moment. So define the, if the question is asked define the term electric dipole moment, then we can write this. And derive an expression for the expression for the total work done, for the total work done. Question में discussion में work done, we have obtained the expression for total work done, and then as we know that total work done is stored as the electric potential energy of the dipole. So if first we have obtained the expression for total work done. So in question find the derive an expression for the total work done in rotating the dipole through an angle, through an angle theta in uniform electric field E. Second related question may be asked. Derive an expression for the potential energy. Derive an expression for potential energy of the dipole in a uniform electric field E, and hence discuss the conditions of conditions of stable and unstable equilibrium of the dipole. So these two types of questions may be asked from this discussed topic, electric potential energy of the dipole in a uniform electric